In this video, we're going to talk about hypothesis testing on one population parameter. Now, like what was said in the previous video, hypothesis testing on one population parameter mainly focuses on if this is our population, and from this population, this is the sample, and as we know from the sample, we will have the x bar as the sample mean, while for the population, we would have the mu. So, hypothesis testing on one population parameter would usually ask if the population mean is actually equal to the mean of the sample. So this will tell us whether the sample can represent the population. Because like what we've known in sampling distribution, we can have more than one sample, and among them, will that specific random sample mean that we got can represent the entire population or is statistically equal to the population mean itself. And not just mean, it can be the population proportion or even the variance. But we will focus on the population mean. Hypothesis testing on one population parameter is usually if you have you're testing for the mean and your sigma, which is our population standard deviation, is known, or this symbol is known, then we would also have, we're solving for the mean, but sigma is unknown. And we also have the one for proportion. But what we will focus on is this two because that is what is more usually used. So the first one, the problem that we're actually seeing now is a sample problem rather for the test 1 population z-test. The one population z-test is used to determine whether the sample mean is the same as our population mean. So the one population z-test is used if, number 1, our sample size is greater than or equal to 30. And this is, if you remember, part of the central limit theorem. That is the first condition. So as long as our sample size is equal to or greater than 30, then we can use this test. Another one is that if the sample size is less than 30, but it is normally distributed. As the name implies, it is a z-test, meaning we would need it to be a normal distribution because we're using z-test here. So, again, the two conditions for us to use a one population z-test is that 1, the sample size should be greater than 30 by the central limit theorem, or if the sample size is smaller than 30 but it is normally distributed. So, how do we do one population z-test in Excel? Let's have this example. A researcher claims that the average cost of men's athletic shoes is less than $80. He selects a random sample of 36 pairs of shoes from a catalog and finds the following costs in dollars. The costs have been rounded to the nearest dollar. Is there enough evidence to support the researcher's claim at alpha equals 0.10? We have to assume that sigma is equal to 19.2. We have to make sure first that this problem is actually for one population z-test. And how is that? Here we see that the random sample is actually 36. So 36, as we all know, is greater than or equal to 30. Therefore, it follows the first of the two conditions of, of using one population z-test. Therefore, this can be used as one population. This can be tested rather for one population z-test. So, how do we now do the hypothesis test? Remember, we have 4 steps. Step 1 is to state the null and alternative hypothesis. Step 2 is to compute for the test value to be used. For step 3, which is actually computing for the p-value. And then step 4, we do our decision and interpretation. In the next video, we're going through the different steps of hypothesis testing, doing one population z-test.